when we move from vertex form to standard form of a parabola, doesn't mean it's going to change. It's still going to be one of those U-shaped guys. Bless you. But finding the vertex gets a little more work to it. Because now instead of just being able to look at the equation and saying, oh, it's this point, it doesn't quite pop out. So here's what we've got to do. We are going to have to calculate, and it's just a real quick calculation, the vertex for each standard form. Here's how this works. We've got to label our points. Now, I've made note for us up here what our A, B, and C values are going to be. So we're going to start each of these problems by labeling those. So for instance, on number 1, my A value would be -2. It's whatever number's in front of x squared. My B value is -12, whatever number's in front of my x term's coefficient. And then my C value, if there's one, would just be the number that's sitting on the end. And from those two things, I'm going to be able to find some different info. For today, the only two letters we care about are A and B, because they allow me to find the H value or the X value of my vertex. So my first step is going to be to plug. So we're going to do -B. You're like, well, it's already negative. Doesn't matter. Put the negative there because that's part of the formula. Then stick in my B value over 2 times A. Okay, this is always my first step, and it's going to help me find my X value of my vertex, this H. So what happens when we do a double negative like this, when we're multiplying a negative times a negative? It becomes plus plus. But then 2 times -2 is -4. Okay. And I can find my H value, the first value in the vertex of my expression. Now, here's where I go a little bit different from most people. My K value, and we kind of made a note of it over here. You notice how these kind of look the same? Except you're like, well, yeah, except that turned into K and that turned into H. What's up with that? All that means is, when you're thinking about a vertex, it's really like my X and Y values. It's still a point on the graph. We just use different values because it's a parabola form now instead. So once I get that figured out, I got one more step I got to do. I'm going to go back to this equation. This is my number 2 job. This is my number 1. In each of those places that I see an H, I'm going to plug it in. So here's how this works. I'm going to take my equation I have here, and every place that I see this X, I'm going to replace it with my H value. Notice everything else, and we're going to use the calculator to do this, stays the same, except when I get to the variable part. That's when I'm going to change up my values. So I will get this out of the way in a second. I know I've got my screen right in the way of you here. We'll get that taken care of very quickly here. Again, great calculator to have. Okay, there we go. So now I'm just going to type this in exactly like I see it. So -2, -3 squared, minus, and there's a difference between the minus and the negative button. I know it's hard to believe sometimes, but there is. So 12 times -3, and then minus 15. The only time I'm going to use the negative is if it's one of these values I'm putting into the parentheses. Now, let me make sure I typed it in right. -2, -3 squared, minus 12, -3, minus 15. Yep, that's right. So out of all of that, I get a 3 which is my k value, which then lets me write my vertex, which is a coordinate point. This is the one bad thing about things being in standard form instead of vertex. I gotta do a little bit of extra work. Not the worst thing ever, but not the greatest thing ever either. But it's only going to be those 2 steps, because then I'm going to be able to do what I was doing back on Thursday and Friday, where I can just use my step over to come up with the rest of the points. So let's see. On this next one, and I won't have you do 8 of them because that'd be overkill. What are my A, B, and C values for number 2? Any takers? Okay.
Square.
We'll get there, but yeah, just the negative. I just want the coefficient so far.
And 12.
Okay? All right. And I got to make sure with each of these, if they have whether it's a plus or a negative. Okay? If it's a negative, I need to make sure I take that with me. Because once I get that, my h value is just negative b over, I second that, 2a. And then again, it's just being careful. And I wouldn't suggest doing this first part in the calculator, because with the divide, sometimes order of operations can become an issue. So the opposite of negative 12 is 12. 2 times negative 3 is negative 6. And then I'll just divide. So I get my h value that way. And then just like what we did on the first one, I'm going to take my original equation, and the only thing I'm going to do is anytime I get to an x, I'm going to plug this value in. And I kind of like letting it jump out with the numbers. Now, this is a place that I would trust the calculator. And as long as I'm typing it in just the same way I have it there, it should work out well for me. So I have a negative 3 times negative 2 squared minus 12 times negative 2 minus 8. Okay, that's my k. And then I just write the 2 in a coordinate, and I get the answer. Trying to see if there's any that are going to be especially crazy or tricky as we go down here. I'm going to skip past 3 and 4, because I want to get us into some positive, negative stuff here. We're going to do 5 and 7 to kind of change things up a little bit. Same process though. So when I'm doing 5 and 7, I still want to write down at least my A and B values. I know we said we're not using C today, so at least I should write down A and B. And then again, my first step is always to do negative B over 2 times A. And even though my 16 wasn't negative, it's just a good habit to put it into parentheses, because then when it is negative, you don't mess this up. So I've got negative 16. 2 times negative 4 is negative 8. And we've already said a couple of times today that negative times negative is positive. So I've got the x value of my vertex, my h value. And then again, when I get here, I'm just going to take that h value and I'm going to plug it in where the x was. Bless you. So I'm like, okay, so negative 4 times 2 squared plus 16 times 2 minus 20. Just substituting my newly found value in there so I can actually get a value for it, my k. And again, if you are a multiplying star, I would go ahead and just use my brain. But if you're not feeling that good about it, no problem. And then I just rewrite those. And that would be, if I were to type this up on the graphing calculator, that would be my middle point. You're like, now, seriously? Yeah, we're not going to graph today, but I just want to show you how you could see this sometime and how you will when we start graphing these tomorrow. So if I were to type this in on my calculator and hit graph, remember, a vertex is the point where it changes direction. It would be like right here. So if I started looking, and remember we talked about how we know where a vertex is because the numbers above it and below it would be the same, and you see the symmetry with the -8, the -20, and the -40. So you're like, why don't I just do that on all of these? Because sometime you may get a vertex that's a decimal number, and then you're not going to be able to see it on here. So we always got to have the backup plan ready. So if we don't have a backup plan ready, that can get kind of ugly. And then I guess what I'll do, since all of these values are right here and so close, is we'll just do number 6 right next to it. What number is in front of x squared when I don't see 1? 1. So I get my a and b, because again, those are my critical values for right now. And my first step is to do negative b over 2a. We've already said negative times negative is positive. So then 6 divided by 2 will get me my h, the x value of my vertex. And again, we're just going to plug those in where the x's are, because x and h are in that same spot when we're looking at a coordinate. So my k is going to equal, okay, I'm going to plug in the -3. Oops, it's positive though. I don't want to plug in a -3 if it's positive. Bad idea. So 3 squared minus 6 times 3, because again, we're plugging that in where the variable's at, plus 6. Give it one more run through the old calc here. Get that last value. So I've got 3 squared minus 6 times 3 plus 6. Looks like a -3 for my k. It should be 3, -3. And just for fun, let's see if the graph agrees with what we just did. Graph that. Let's see, 3, -3, it looks good visually. If I get my 3 in the middle, yes, -2, 1, 6. I see my symmetry. So I see that's going to work. But today our main focus isn't the graph, it's just find the vertex. Because then we'll be able to graph the rest of it pretty easy after that, just using our steps. Now, like I said, we're going to do some reviewing with this though, just so things don't kind of go out of your brain by the time we get to finals. So if you take a moment and flip over, we're going to do a little bit of review back here. And there's a little bit of review on the worksheet, but it's nothing too bad. We're going to solve by elimination. Now when we do elimination, we always look first to see, if I add down right now, can I eliminate a variable? And if I can, that's awesome. 4x plus negative 4x, that's what I'm talking about. And then I can just add down with what's left. Negative 5 and negative 3 is negative 8. Negative 11 plus 19 is positive 8. And I just have a one-step equation. Life's not too bad. But again, I'm not adding 8 here because I'm multiplying that times y. So I have to divide. And unfortunately, I'm not completely done yet. Because I know what y is, but I still need to know what x is. So if we remember back for a little bit, what we used to do was just say, oh yeah, I'm going to take that first equation, and then I'm going to plug this value in where the y is at. So I go, okay, let's see. What do I have to do first here? Oh yeah, multiply would come before subtract. So negative 5 times negative 1 is positive 5. And now I'm just going to solve this equation. Well, shoot, I've been solving equations since first quarter. This is easy. I'll minus that 5. Because if I can say, if only one thing I could say about this group, the equation solving is a strength. And I get both my x and my y values. And so for any of them you see today on the sheet, it's going to work that same way. One of those pairs for us, lucky, will cancel. 8 plus negative 1 is 7. I owe somebody 20 bucks and I borrow another 15. Whew, I need to quit borrowing money first. I owe him 35 bucks now. So then what we'll just do after that is we're going to end up putting that equal to 5. So this time I found my x value first, and that can happen sometimes. And then, again, to me it's just easier to keep using the same one each time. Plug in the x value, since it's the x that I solved for. And then just simplify it. Do my opposite. To get my y by itself. And solve for my other variable. And it has. It's been a little while. This is back towards the beginning of the semester. So again, it's something that takes a few steps, but we're not doing a bunch of them. We're just doing a couple to kind of get you back into the flow of things. Power to power on exponents. Now, this gets a little more interesting. This negative that's in front, it's like having a negative 1. I'm going to distribute this exponent all the way through here. So the first time we'll actually look at it kind of written out here. I won't do this on all of them. But I want you to see how this works. So that fourth exponent goes to each part, the number and each of my variable terms. And when we do power to power, we multiply the exponents. So let me start with the variables. 6 times 4 is 24. 3 times 4 is 12. Negative 1 to the 4th power. Now, if you're not sure on this one, not a terrible thing to get some help. Okay, and I see that's going to be positive 1. So I just put that in front. Ready to roll. Okay. You're like, well, what if there's not an exponent there? Remember, if we don't see an exponent, it's just like there's a 1. So I look and I go, okay, so I've got 3 to the 5th power. Holy cow. Okay, notice I didn't do 3 times 5. I multiply the exponents. 1 times 5 is 5. But then 3 to the 5th is 243. But with my exponents, that doesn't happen. 1 times 5 is 5. And the same thing with my y's. And I get my answer that way. Okay. So that's the kicker here. If you don't see an exponent on something, we make it 1. So I've got 4 to the 6th. It's a big old number, 4,096. And then 5 times 6 is 30. Okay. Multiply exponents. That's all we're trying to do. Then our last couple of little review things down here at the bottom are helpful hints. Okay, find the product. We need to FOIL these out. I can't just distribute the squared and call this b squared plus 81. It just doesn't work that way. So the b minus 9 squared means there's 2 of these. And this is going to come in handy in a couple of days. We're going to be doing vertex form to standard form, and here's one of the things we're going to have to do. Now, you can do this one of 2 ways. I'll show you both. One way is just old school FOIL. So you just go, okay, b times b is b squared minus 9b. Negative 9 times b is still negative 9b. And negative 9 times negative 9 is 81. And I notice I have like terms. Okay, b squared is different from b, but these b's are the same. That I can go ahead and add up and get to the answer. And I always know I like foiling. One reason I like doing it this way is it kind of likes that smiley face looking guy. And if I see the smiley face looking guy, it means I did everything I was supposed to and multiplied it out. If all the lines and stuff just confuse you, and for some people that's the case, and that's okay, that's not a big bad thing. Here's my other option. Once I write it out, if I'm a more visual learner, the other way I can go is to do the box. And the advantage of the box is, once you've filled in the box, you know you've multiplied everything together that you're supposed to. K times K will multiply to fill the box. 10 times K is 10K. 10 times K is 10K. And 10 times 10 is 100. And my like terms will always be in the diagonal. So it kind of does some organizational work for me. But once the box is full, now again, I'm just adding and subtracting. I'm not multiplying anymore. And I get it set that way. So does it take up a little more room than doing it just with the lines does? Yes. But if it's that organization it takes you to get it right, that's okay. Okay. Just one more. Again, either way works. Kind of go with your personal pick on this one. P squared minus 7p minus another 7p. Negative times negative is positive. And just put the pieces together. Again, we're adding after the first step to get your value. And then finally, this is a little more recent, when we're looking for distance, again, I have two choices. The formula, which I'll admit is the faster way of doing it, I'll show you the other way too, though, because I know, again, some of you are visual. That's cool. So I would just set this up and I'd say, okay, I'm going to subtract my x's, 10 minus 3. I'm going to subtract my y's, 8 minus 1. You can do them in either order you want. Now, we did talk about this before, though. When I'm doing these, I don't want to try put it in the square root right away. It's going to get me in trouble more often than not. So I'm going to go ahead and do all the stuff that's underneath, but I'm not doing the square root quite yet. I'm just going to do this part. I'm going to get my answer. And now here's what I'm going to kind of let you in on. If you go to do the square root, which again, to get the square root is second and x squared. And you get a decimal. Here's kind of our options that we're looking at. I actually would prefer that you do one of two things. You either leave it like this, just circle it, say, okay, it's square root of 98. Or if you're looking for a little bit of a challenge, which could be a bonus down the road, I start thinking about my perfect squares again. And there's a certain point that you'd have to know these, because when you get out of Algebra 1 and head to Algebra 2, and we're doing this stuff in there and something similar, they're not going to take the decimal anymore. It's going to be, okay, we got to know the perfect squares. One of them breaks down, because the square root of 49 is 7. And I get my answer down into its simplest radical form. Because it's like anything else. If you really do play with the squares for a bit, you'll get to know them. If you're like, I'm not going to know these ever, I don't care, then you probably won't. Okay? But the formula is one way to get this distance. If the formula is not one of your things, if you're like, yeah, me and formulas do not get along. Okay, here's your other option. It's going to take a little bit longer, but it is a little bit simpler. So there's pluses to both of these. And I write my little dots really small though here because I notice I used big numbers. What I'd do is I'd make myself a little graph and I'd plot 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I'd plot the 2 points. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'd connect them with a line once I drew it. And then I'd make a triangle. And by making the triangle, I could figure out how far it is and count. Let's see here. 1, 2, 3, 4, 5. Okay, that's 6. And let's see here. Then this guy is 1, 2, 3, 4, and I'm trying to figure out how long this is. And I can use the Pythagorean theorem. And some of you that are in geometry, you know what I'm talking about. It's where I take each of my legs and I square them up, and I set them equal to my hypotenuse squared. So I'd type this in my calculator. 36 and 16 is going to be 52. Oops. And I would take the square root of that, and I get 52. Now again, I go to the calculator, and I'm like, okay, maybe this will come out nice. Maybe. Square root of 52. Nope. So again, I either want you to circle it, leave it, be done, or if you happen to notice, it breaks down. I can get a 4 out of there. That's a 13. I can get 2 square root of 13. Again, this is Algebra 2 level. If we get to this right now, that's okay. But that's what's going to be coming. That's what the expectation's going to be moving forward. So your job in all of this is on the other worksheet, which basically has the exact same stuff on it that we just did here. It's almost like a replay of it. Okay, calculate the vertex. Keep your note sheet available, but here's your big one. Get that h value, and then your k is just going to be plug it in. Plug h into equation and solve. And this guy is homework check 11, number 2.
So